Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's very easy puzzle, and it's called Four Finger Death Punch by Jonesy. And here are the rules. Hello, hello. Normal 9 by 9 Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Draw a one cell wide loop that moves strictly orthogonally and doesn't branch or intersect itself. The loop doesn't touch itself, not even diagonally. So orthogonally just means that they share a loop, or sorry, share an edge. So basically, on the loop, a valid loop would be something along. Oh, that would not be a valid loop. But a valid loop would be something along the line of. Ugh. Something like this would be a valid loop, right? Because it's connected orthogonally, and it's one cell wide, and it doesn't touch itself, or branch, or intersect. An example of an invalid loop would be here, like because we took out essentially one of the cells. Now it's not connected orthogonally to each other. These are connected diagonally, but unfortunately that's not sufficient. It has to be connected orthogonally. And another way that this loop could not work, is say we went this way instead. Whoops. If we went this way, the problem is that it's touching itself diagonally, and that's not allowed. Because obviously it goes in through here, it touches itself, and then it goes back out. It doesn't actually just connect. So that would also not be a valid loop. And the loop acts as a German whisper line. Neighboring digits on the loop must have a difference of at least 5. So for example, if this were a 3, this would have to be an 8 or a 9 to be a neighbor on the loop. Say this was the loop. Then basically, if this was a 3, this would have to be an 8 or a 9, because you can't have adjacent digits on the loop have a difference of less than 5. Okay, a digit in a circle indicates how many times that digit must appear in circles. A circle digit also indicates how many of the up to 8 surrounding cells are on the loop. Circles are never on the loop. So this loop doesn't work because you have circles in the loop, even though the circle says how many, even though the circle does not have, cannot be on the loop. So circles are never on the loop. A circle digit in a circle indicates how many times. Okay, so say we ignore these circles here. What do the digits in the circle mean? For this one, this would be basically 2, because of the 8 surrounding cells around it, 2 of them are on the loop. This would be 4, because of the surrounding 8 cells, 4 of them are on the loop. This would be 1, 2, 3, 4, 5, 6. So of these cells, there would be 6 on the loop. This would be 3, etc., etc. This would be 5. This would be 3. This would be 3 also, which tells you something about this not being a valid loop. So those are examples of what they would be. In addition to that, it indicates how the digit on that must appear in the circle indicates how many times that digit must appear in a circle. So if this was a 2 and it was valid, that means there has to be another 2 in another circle somewhere, right? Because there must be 2 2s in circles. Same for this. If this was 3, that means there would have to be 3 3s in circles, which actually it works here because this is 3, this is 3, this is 3. If this was 5, if the 4 was in the circle, this would indicates that there has to be 4 4s in circles. This would indicate there's 5 5s in circles, but obviously this can't work correctly because there's too many digits now in circles, and we only have so many circles. Anyways, those are all the rules. If you like to play along, there's going to be, again, remember, the digit in the circle does double duty. It basically tells you how many digits appear in circles, how many of that digit, sorry, appears in circles. So it says, this says there's two digits that also, there's two twos that appears in circles. And in addition, it says how of the surrounding 8 cells of the circle, how many are on the loop. So this says that there are 2 of the 8 surrounding cells are on the loop. And those are all the rules. If you like to play along, oh, have fun too, also, which we will try to do. Those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so quick thing then. Count how many circles there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We know there's 3 different digits at least in the circles. There could be 4, so it could be 1, 2, 3, 4. That is possible. In addition, so the possibilities in the circles are 1, 2, 3, 4, 1, 2, and 7. Except that there's 1, 2, 1. So there's 1, 2, 3, 4, 5, and 6. So 7 cannot be actually in the circles because there's only 6 boxes have circles in them. And obviously it has to be different for each one if it's 7, right? So there would have to be 7 circles in 7 different boxes to have 1, 2, and 7. So that does not work. It could be 1, 3, and 6. That is possible. So of the circles, again, there's 10. It's either 1, 2, 3, 4. It's 1, 3, or 6. It could be 1, 4, 5. Can it be 1, 4, 5? Maybe. 1. I think so, yeah. 2, 3. Yeah, it's possible. There's 3 here. It could be 1, 4, 5 or 2, 3, 5. And those are the possibilities that we have for numbers in the circle. So it could be, again, 1, 2, 3, 4, 1, 3, 6, 1, 4, 5, or 2, 3, 5. None of the circles are on the loop, so it cannot be here. Let's see. They all have at least 1, so it could be 1 through 6. Obviously this can't be 6. Could it be 1? It's not really possible for this to be 1, right? This is, again, could be here, along here. That's possible. It must touch one of these two. So it either goes in here or it goes in here, I think. It cannot, it could go something like this, actually. And then this goes out that way. The problem with this, though, so say it went in this way. So it obviously could go in here. So if it goes in here, it has to go out, right? And it goes out either this way or this way. What, though, happens if we go out this way? This becomes at least 6. This is at least 7, which is not possible. So it cannot go in this way and go out this way. It has to essentially go out this way. Even that, is that even possible? So say it goes out this way. This would be 1, 2, 3, 4. This would be 1, 2, 3, 4, 5, 6. And already those two add up to 10. And therefore, this would have to be at least 1. So that's 11. So we would expect at least 11 circles, which is not what we have. We have 10 circles, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one never work. So it can never enter in here and exit out this way. So it always has to at least enter in here. So it enters in here and it must exit out this way. At least. Therefore, this is at least 3. It can't be 5 because it doesn't cover the whole thing. It could go here, so this could be 3 or 4. This is at least 5, and it could be 6. So this has to be, it cannot be 1, 2, 3, and 4. Therefore, we know it's 1. It could be 1 or 2 with 3 or 4 or 5 or 6. This is at least 3. It cannot be 5 and 6, though, right? Because if this is 5 and 6 and this is 5 and 6, that doesn't work. Because that would then add up to 11 for the digits, right? And they have to be different digits. So therefore, this cannot be 5 or 6. It's 3 or 4. It cannot be 4, because if it's 4, it just stops here. And that doesn't work. So this one has to be 3, which means this one cannot be on the loop. These can't be on the loop. None of these could be on the loop because it can't enter and then exit to get on the loop. Therefore, this is 3 or 4. This has to be 2 then. Since this is 2, we know this has to be 3 and 5 then. So this is 3, and this is 3, and this is 5. So it cannot enter in here, because then that would be 4. It cannot enter in here, because then that would be greater than 5. So these are not on the loop. So that you can only have 2, 3, and 5 on the loop. This has to be 5. This can be, again, 2, 3, or 5. This is 2, 3, or 5. These are 2, 3, and 5. And in addition, we know the 2 has to be here, because of these, there are 3 different digits here. One of them has to be 2, one of them has to be 3, one of them has to be 5. So that's the other 2 that's in a circle is here. So this cannot be 2 here then. This cannot be 2 here. This must be 3 or 5. In addition, since this is 5, we know this loop has to cover the rest of the 5 remaining cells here. This has to go here. None of these can be on the loop because they are would touch it. This can't be on the loop because it would touch it, so it must go here. This is 3 or 5. This is 5, this is 5. This has 1, 3, and 1, 5. So therefore, these both have to be 5. Because we don't have enough 5s otherwise if we don't, right? There's at least 1, 3 here and 1, 5. And we know we already have 2 3s here. So therefore, one of these is 5, one of these is 2, and one of these is 3. So therefore, these have to be 5 and 5. Since this is 5 and 5, the remaining 3 have to be here, which means they connect this way. This cannot be on the loop because it can't touch it. If it goes this way, one of these has to be 5. So say it went here. One thing it cannot do. Okay, so say it avoided this one. So we have 5 here. Possible. Excuse me. What you cannot have is having going this way and then coming back here. Right? Because then this would be too much for this circle. So this must be on the loop. We tried without, with those 3 and those 2. How else does it go through? It goes there, but then this has to be 7, which is not possible. So it has to go through here, which means it must contain all 3 of these, because there's no other way possible to not go through here. Therefore, this has to be the 3, which means this can't be 3. Therefore, none of these are on the loop. In addition, you cannot have any of these be on the loop because it has to go through here, and then it would have to go double back, and then it can't connect with the loop again for that to be possible. So none of these are on the loop. This technically could go here or here. It has to go one of those two, actually. So therefore, it cannot go to anywhere else on the loop because anything else would be touching itself, considered touching itself, right? So if it went this way, that's touching itself here because it's not continuous here. So it connects to one of these two. This must go up. So it's either here and not here. The thing is, okay, so this can never be 5 now because there's only 4 possibly open. So this has to be 2, which makes this the 5. So for this to be 2, it cannot enter in and then exit out. It couldn't do that anyways. So how does it get 2? It cannot touch either of these, right? It can't just enter in and then not exit out. It can't enter in here and then exit out. So therefore, this must be on the loop, which means none of these two are on the loop. Which means we know that these have to be on the loop to make this a 5. Therefore, this cannot be on the loop. Therefore, this is on the loop, which means this can't be on the loop. This cannot touch, so it cannot go this way. So it has to go this way. These are not on the loop. This must go this way. Can't touch, so this one's not on the loop, which means these two are the last two on the loop, which means these can't be the loop. And this can't be the loop. So now we have, let's see, none of these can be 3. We know there are 2 lows on this loop. So on the German whisper line, first of all, you can't have 5 because 5 is not 5 away from any other digit. In addition, you always alternate on a German whisper line between lows and highs because 1, 2, 3, 4 can only be next to 6, 7, 8, or 9, right? Because 1 has to have a digit that's neighboring digits that are at least 5 away, which is 6 through 9. And 9 has to have at least neighboring digits which are at least 5 away, which is 1 through 4. So it's always alternates between low, which is 1, 2, 3, 4, and then high, which is 6, 7, 8, 9. So on this loop, we know it alternates between low and high. So it's always low, then high, then low, then high. Therefore, we know there's 2 lows here and 2 highs here. But the lows can't be 2 or 3. It has to be 1 and 4 because the 2 can't be here because of this 2. The 3s can't be here because both of these are 3, and that eliminates all possibilities for 3. Therefore, there must be a 1 here, and there must be a 4 here. Where can the 4 be? The 4 cannot be here because 4 can, on a German whisper line, can never be next to 2 unique numbers. And this is next to 2 unique numbers. This is also next to 2 unique numbers, so it can't be a 4. This is also next to 2 unique numbers, so it can't be a 4. Where is the 4 then in this set of German whisper lines? It can only be here. So this has to be a 4, which means it's next to a 9 and a 9. So now we know all these cells are specifically low because, again, it always alternates between high and low on a German whisper line, right? So we know these are all low. So we're going to mark them as blue. These have to be all high because they are so this one has to be 1. This cannot be 9. So this has to be 6, 7, or 8. But it's next to 2 unique numbers, so it cannot be 6. So this is 7 or 8. This could be 6, 7, or 8, except that this can't be 1. We know for certain, then, this can't be 4, because 4 has to be next to 2 9s if it's on the loop. So it can't be 3, so it has to be 2. So this is 2, which makes this 7, 8, or 9. Can't be 9, though, so this is 7 or 8. This can't be 4, obviously. Can't be 2 or 3, so this must be 1. This could be 6 through 9. This can't be 1 or 4, so this is 2 or 3, which means this is next to, cannot be 6. It could be 7 or 8. This can't be 2 either side. This is next to 2 unique numbers, so it can't be 4. Well, it could be 4 anyway, so this is 1 or 3, because it can't be 2 here. This cannot be 2. It could be 1, so it could be 1 3 or it cannot, it could be 4. This is not 6, but it could be 7, 8, 9. This is 1, 3, or 4 also. This is 6, 7, 8, 9. This is 6, 7, 8, 9. So we know one of these is 6, 7, 8, 9, and we also know this is 1, 3, or 4. So this is 1, 3, 4, 1, 3, 4, 1, 3, 4. 6, 7, 8, 9. This is 2, 3. It cannot be 4 because it's next to two unique numbers. In addition, the 6 has to be next to a 1 at all times on the loop. So this can't be 6. This can't be 6. Therefore, we know this is a 6, which means this has to be 1. Which means this can't be 1, this can't be 1. We have a 3, 4, 3, 4 pair. Therefore, 7 cannot be either of them because it's next to at least a 3. And 7 can never be next to 3 or higher. So this has to be 8, 9, 8, 9. Therefore, this is a 7 because of the 8, 9, 8, 9 pair in row 7. Therefore, we have 2, 3, and 4 left. Oops. 2, 3, and 4. This can't be 4, so therefore this has to be the 4. This can't be 2, so it can't be 4 either, so it has to be 3. Which means this can't be 3, this is 2. This is 1, 3, or 4. This is 3 or 4, this is 3 or 4, this is 1 or 2. So this is 3 or 4, which means this has to be 8 and 9. So therefore this can't be 4 because it can't be next to two unique numbers. Therefore this is 3, which makes this 4, which makes these 9 and 9. Therefore this is 8, which makes that 9. This could be 6, 7, or 8. This cannot be 2. So this is 1 or 3. It cannot be 4. So this is we have a 1, 3, 1, 3 pair in row 3. Therefore, the rest of the row cannot contain a 3. Therefore, this is a 2. This is 1 or 3. This is next to two unique numbers. It cannot be 4, so it must be 1 or 3 also. Therefore, this is next to a 3 in both ways. So it has to be 8 or 9. This has to be at least next to a 3. So this is 8 or 9 also. This has to be next to at least a 3, right? It's either 1 and 3 or 1 and 4 or 3 and 4. So this is also 8 or 9. Can't be 9, therefore this must be 8, which makes this a 9, which makes this an 8. Therefore, this has to be then 1 and 3. So this is not 4, this is 1 and 3, this is 1 and 3. Right. And now I think we pretty much just do Sudoku. Let's see. So what we have here is, so this is, again, just to reiterate, this has 3 that it sees. This has 2 that it sees on the loop. This has 3 that it sees on the loop. This is 5. This has 5. This has 3. This has 5. This has 2. And this has 5. And this has 5. So that works, and we have 5 5s in circles, we have 2 2s in circles, we have 3 3s in circles. So in addition, we know the 3's here, we know the 3's here, so the 3 has to be one of these two, therefore this must be a 3 by Sudoku. This has to be 3, this has to be 3, this can't be 3, this can't be 3, therefore this must be a 3, because we know there's a 1 3 1 3 pair here. So the rest of the column must have a 6, a 4, 6, and a 7. Is that right? Yeah. The 6 cannot be here, so this is 4 or 7. This has to be 4, 6, or 7. 2 can't be here, 2 can't be here in box 5, therefore this must be a 2, which means this can't be 2, so this is 1. So this still could be 6 here. There has to be an 8 here with 4 or 7. So that's fine. This can't be 4. So neither of these two can be 4. These can't be 4, obviously. Where is the 4 in row 4? It has to be one of these two. So this cannot be a 4. This cannot be a 4. 2 can't be either of these. Can't be here. The only possibility now for 2 has to be here. 2 can't be here, 2 can't be here, 2 can't be any of those, so therefore the 2 is here specifically. Where is a 2 in box 7? It has to be here. So now we have all the 2's accounted for. What about the 1's? The 1's have to be in rows 1 and 3 in both here. Therefore, as an X-wing, they cannot appear in rows 1 and 3 in the rest of those rows. So this can't be 1 or 3, this can't be 1 or 3. Where's the 1? In row 2, it has to be here. So because of that, we know 1 has to be one of these here. 1 cannot be in column 8 and column 9, so therefore it must be in column 7, and the only place for box 9, so therefore this has to be 1, which means this can't be 1, which means this has to be 1. We have 6 and 7 left over in column 7, so that works still. This has to be 5 in 6, 7, or 8. 5 cannot be here, 5 cannot be here, therefore this must be 5. Let's see. This is a 1, 3, 1, 3 pair in row 3, therefore it cannot be 1, 2, 3, 4, 5, or 9. So the rest is 6, 7, or 8. This is 6 or 7, so this can't be 8. This is 6, 7, or 8. We have a 6, 7, 6, 7 pair, in addition to a 1, 3, 1, 3 pair in box 3, which leaves the last rating digit being a 4. So this is a 4. Therefore, this in row 2, we have still 6 and 7 remaining, so that's 6 or 7. 4 has to be one of these. Oh, this can't be 8 anymore. Therefore, this is a 7, which means 3 cannot be next to it, so therefore it must be 1. This must be 3. This must be 1, and this must be 3, which means this can't be 6 or 7. It has to be an 8 to have 5 next to it on the German whisper line. So this is 8. Now we just really do just Sudoku. So this can't be 7, therefore this is 6, this is 7, this is 6, therefore this must be a 7. This can't be 6 or 7, so this must be 8. This can't be 7, so this is 6. We have what? 4 and 9 left. This is 4 and 9. We have 5, 6, and 7 left. This can't be 5 or 7, so this must be 6. We have this must be 5 or 7. What is here? This is 4 and 8, and this is 4 and 8, but this can't be a 4, so therefore this must be an 8, which makes this a 4. Okay, what do we have left here? This is, we have 4 and 6, so that's fine. And this is what? 5 and 7? This is 5 and 7. This is 4, 8, and 9. And 8 cannot be here, so the 8 can only be here. So this is 4 and 9. Oops. This is 4 and 9. This can't be 9. These can't be 9. Where's the 9 in box 7? It has to be here, which means this can't be 9, so this is 4. This can't be 4, so this is 6, which makes that a 4. Makes that a 7, which makes this a 5, which makes that a 7. Therefore, this is 5. The last remaining digit in box 6 has to be, or box 7 has to be 6, which makes that a 9. This can't be 5, so this is 7, which makes that a 5. This has to be 8 because of the remaining digits. Therefore, this must be 6, and this must be 7, which makes this an 8. This makes this a 6. This can't be 6 or 7, so this is 4. This can't be 4 or 8, so this is 7. This can't be 9, so this is 4, which makes that a 9. And that's the solution. Yay, congrats. Pretty straightforward. Yeah. I hope you guys understood the logic. It was pretty straightforward, I felt, but maybe I don't know if I explained it the best. Anyways, I hope you enjoyed this puzzle, and I'll see you next time on Frank Puzzles. Take care.